is my distinct honor to welcome Eoin Woods to speak to us and to congratulate him on winning the most prestigious award in software architecture. So a little bit about Eoin. Eoin's been in a number of companies over the last 20 years, building complex software solutions. Right now, he's CTO of Endava. It's a European IT services company that's fast growing. That seems like a big day job. But in addition, Eoin has been a rock star in the software architecture community. His book, Software Systems Architecture, is widely read if you haven't read it. Mine's all dog-eared and marked up. Wonderful book. And he writes the column, Pragmatic Architect, in IEEE Software. And so you can catch that every month in IEEE Software. If you are not a fan of software, or a UK accent, and who isn't a fan of a UK accent, you can enjoy Eoin's other hobbies. He's a brilliant trumpet player, and he likes fast machines, Formula One, so you know when he's out of this biz, made his money, expect to see him on the race circuit. So congratulations, I couldn't be happier. Here is the award for Eoin Woods, who's done an awesome job in contributing to the software architecture community, and I look forward to your talk. Congratulations.
Thank you, Linda. Okay, good morning. It's very nice to talk to you. Thank you for having me. There's a couple of people I should say thank you to immediately. One is Linda Northrup for having worked extremely hard for so many years and had such a distinguished career. She got an award named after her, because otherwise I wouldn't be here, so thank you, Linda. And thank you to all at the SEI who run the award. Thank you very much indeed. It's a great honour to receive it. I've also got to say thank you very much to Elcho, who believed in me and decided to nominate me and did all the hard work, so thank you, Elcho. And also for all the contributions he's made over the years, which have certainly influenced me and many other people in this room. But the other person who doesn't come to SATURN, sadly, is Brzezinski, and he is a long-time collaborator of mine. He's the co-author in the book, but we've collaborated on nearly all the software architecture stuff that the two of us have done over the last 20 years. And thank you also to the software architecture community. It's a really good one to be part of, that's why we're all here, but you've all been tremendously supportive, challenging, creative, and you've been a marvellous community to be part of. And still will be, to be clear, I don't think you're going to die. So briefly, I'm the CTO at Endava. We do software engineering, mainly for other people, and before that I built products for quite a while, and then I did capital markets applications for quite a while. So I'm going to talk to you about a theme which I've been thinking about for a while called Systems Are Dissolving. Now, this is a slightly shorter version of a longer talk. Those of you who know me have already had the thought, Eoin Woods in a 30-minute slot. Really? I'm going to move quite fast, but I think we can get the essence of it over. Because what I've noticed is over the last 20 years or so, as I've been in the industry, we used to build systems that looked a bit like this, everything very tightly packed together. Big binary comes out of the pipeline. We didn't have a pipeline, did we? We had a make file, but a big binary pops out the bottom. And then a bit later on, we decided that that was becoming too easy, so we were going to put networking in between the bits. But the bits were still quite big, so we thought that had become too easy. So then we decided to break it down into even smaller bits, connected in ever more complicated ways, ideally ways that weren't obvious from the code and were only obvious at runtime. And that's kind of where we are today with microservices. And then the next step seems to be serverless, where we're going to deploy the smallest conceivable piece of code as a first-class object in our runtime systems. And this has had some, I think, fairly profound implications for software architects. There's 5 very distinct phases I think this happened in, it sort of lines up almost with the decades. It's a sort of George Box moment. He's the man that said all models are wrong, some are useful. If don't look too hard at the dates, they don't quite fit the phases, but actually as a model it works okay. Up to the 80s, that was the kind of monolithic era. Mini computers, you know, mainframes, all that stuff, big monolithic blocks. Then in the 90s, we broke the monoliths apart, but we still sort of had monoliths. They were quite big things we connected. And then about 2000, the internet came along, So we thought the smartest thing to do was to connect the monoliths directly to a public internet. Those of you who worked through the dot-com boom will remember that didn't end well. However, we learned quickly, being the software industry, and we learned how to integrate the internet as a core part of our system. And that's where we are today. And we're still really figuring this out, quite frankly. There's lots of our clients, some of our clients are completely at home with it. Some of them are really trying to figure out how to integrate the internet into their systems. But we're definitely on the road there. I think the next phase, and it might arrive before 2020 because it's starting already, thanks to pioneers like Google. I think the next era I've dubbed the intelligent connected era. I think there's going to be an awful lot of things connected together, many of them very, very small. Many of them we'll have very little control over. Many of them, in fact, we won't know very much about, but they'll all connect into our system to create the overall fabric. And what's happening is that people are expecting their systems to be a lot smarter than they used to be. Now, we can have a debate about whether they're really intelligent, but to the person in the street, something like Google Maps almost seems magical. It's that kind of intelligence, and people will expect that in our corporate applications. So quickly look at the historical phases. The monolithic phase was when we wrote large amounts of code. Now, I'm not quite old enough to have been in this era, though I encountered some of its technology when I joined the industry in the very early 1990s. And the big concern we had was, how do you structure a program? And things like composition and avoiding go-tos and procedures and collections of procedures and modules, stuff we just and classes, stuff we just take for granted today. There was a time we didn't understand that, and people like Nygaard and Dijkstra and Michael Jackson and Tony Hoare and Pamela Zave and lots of others spent immense amounts of brain power figuring that out for us. And those have been very enduring ideas. And in this era, it was very much batch processing dominated. And I remember the shock of moving from Unix to a mainframe system and realizing that all I could do was ask it to go away and do something, because I'd completely come from that interactive era. And this era, what happened? Well, my thesis under this whole talk is that software architecture, software development in general, but especially software architecture and design, reacts to the challenges that are thrown to it. And it has reacted very, very effectively for a number of decades, and I believe it will react again. It's just that I can't tell you yet how it will have to react for the next era. I'm only guessing. But a guess is better than nothing at the moment. So in this era, the challenge was, how do we structure programs? The answer was, we're going to figure out the fundamentals of modularization. And where was architecture in all this? This is something I vaguely remember, because at this point, I'd just come out of college. I had no idea what architecture was. I mean, the term floated around, but I mean, it wasn't well defined. Actually, an architecture was defined by a vendor. And those of you with grey hair will remember this. People ran on the DEC architecture, more specifically the VAX architecture. Or if IBM had many architectures, they always had five ways of doing everything. So they had the AS400 architecture and the MVS architecture. And the vendor just defined everything. You bought the hardware from them, and then they'd sell you an operating system, and then they'd sell you a compiler and a linker and a screen system and a database and a TP monitor. It was a marvelous time to be a vendor. It didn't last forever, but it was a marvelous time. And really, they defined the architecture. So they drew you a big picture, what we today would call a reference architecture, and they said, you pop your code in those places, don't go thinking now, you just pop it in, and we'll run it for you. We'll take care of it. That's our platform. That's how it works. Completely different to what we're about to go to with serverless, clearly. And the next era were the distributed monoliths. So this is kind of when I entered the industry. And we had 3 building blocks now, which was absolutely radical. We got clients, not very exciting clients, big, thick clients. And we got servers, in some cases. And we'd always got databases. And I actually had the privilege of working for Sybase for a number of years. And Sybase was one of the firms that popularized client-server and absolutely tried to invent it and reinvent it. And although today these seem very, very pedestrian abstractions, I remember actually having to explain client-servers and databases to clients, and it was genuinely a very new thing. And the thing from a developer's perspective, which was a bit bewildering, was this move to online. And what did online imply? It implied concurrency. Because in a lot of the mainframe and mini-computer environments, they actually, because they were such rigid architectures, and you just put your code blocks in the right place, They just looked after the concurrency for you. As far as you were concerned, there wasn't any. And who was working at the dawn of the relational database era? Who remembers deadlocks? Well, we still get deadlocks, but remember the happy hours we spent with query optimizers and plans looking for deadlock problems, and how we'd indexed our tables, and the optimizers weren't that good, so they sometimes created the deadlocks for us. It was a completely new problem for many developers. So what happened? Well, people realized they were having to start making decisions, and decisions that actually they hadn't had to make before, and they coined the term architecture for these. And they started talking about architectural decisions. And so the basics of software architecture started to emerge. So this is in the 90s. So for example, Philippe Cruchten and his team at Rational were doing this out in the field, and they came together and said, there's got to be a standard way of writing this down that would be better than what we're doing. And they came up with 4+1. And then, of course, the famous story, IEEE software needed an article in a hurry, and somebody called Philippe, and Philippe went, yeah, we've got this 4+1 thing. I don't know if anyone's interested, but we'll write it up. And it's become, one of the seminal articles. So software architecture emerged, but it was a bit of a specialist topic. It wasn't the kind of thing that you had big conferences for. It was the sort of thing that very small online communities knew about. And here's where, for example, the SEI started emerging. The SEI became interested in software architecture. For the SEIers, what was the first SEI technical report on software architecture? What date was it? You must know, Linda. 1990, Studying Software Architecture Through Design Spaces and Rules by Thomas Lane. That was, when I checked your database, that was the first time the SEI did a technical report on software architecture. So they were really there at the very dawn of this field. They were one of the first groups to be talking about it seriously. And so what did the vendors do? Well, I was working for a vendor at this time, and we thought it was very, very clear. We produced software to do the client, it's called Power Builder, and we produced the database, and if you wanted a middle tier, we'd got something called EA Server, so just buy it all from us. But some clients had the audacity to try and use Microsoft's front-end tool with our database, which we thought was rather rude. And a lot of people bought Power Builder, and they wanted to use it with Oracle. I mean, it seemed quite insulting at the time. So, of course, to try and we realized architecture, and Sybase was a very architecture-driven company, architecture was a potential way to get the narrative back. So we all defined what today we would call architectural styles, and then we just called architectures. But we educated our customers, meaning we vaguely patronized them and told them what we wanted them to do. We told them about client-server, and we defined the style for them. And of course, the hope was they'd follow our style, and what do you know? Our style happened to align remarkably closely. It was quite a coincidence, remarkably closely with the product line we were trying to sell. I'm sure it was totally coincidental. But that's what vendors were trying to do, is constantly bring the narrative back to the vendor, put the vendor back in control, much as we love them. And then along came the internet connected era. And this is when I really started to look. I did a bit of architecture work at Sybase, but I really started to learn about it at this point, partly because it was suddenly really important. For people who lived through the dot-com boom, what machine's in the picture? It's the classic internet VC-funded Sun Microsystems machine. It's the E10000. Does that ring any bells? So there used to be a conversation. Startup gets funding. Startup calls Sun Microsystems. Sun Microsystems go, oh, your startup, fantastic. Have you got funding? If they said no, they put the phone down. If they were funded, Sun said, right, so you'll be needing some servers. Yes, the startup said, I definitely need servers. I've heard about those. Right, Sun said, well, you're talking to the right people, but definitely the server guys. Are you going to be successful? And the startup went, well, we'll be taking over the world within months, absolutely. All pet food will be through our website globally. So they said, oh, good, we've got a server for that. It's the E10000. You'll be glad to hear it's reassuringly expensive. They were $1 million a pop, these things. How many would you like? And the client would go, oh, I don't know, but one, let's say two, shall we? You wouldn't want to have one down, that's $2 million. And would you need resiliency? I probably said the client, someone told me about that. It's about not crashing, isn't it? Yeah, they said, have you got another data center? Not yet. You'll need another data center. We'll help you with that bit, but of course you'll need some E10Ks for that as well, won't you? Really, said the client, getting slightly panicky. Yes, said Sun, you'll be needing probably two there as well. Before you knew it, they'd spent $4 million. The same phone call happened with Cisco for all the networking kit. Do you want to be secure? Oh, I guess so. You'll be needing a firewall. Well, not one firewall, clearly. Why don't we send a truckload of firewalls? EMC were then doing the same with storage. And it was a repeatable pattern. And these vendors just made out like bandits. You couldn't really blame them, but they really did. It was a clear problem with some inexperienced people spending other people's money. If they'd been spending their own money, they'd have gone, how much? So what we did really in this era at the beginning, in retrospect, was just madness. We took client-server systems, enterprise-style systems, and then we just bolted an HTML front end on them and connected them directly to the internet, and then hoped they'd be really, really scalable, robust, secure, and fast. What do you know? They weren't. And if anyone remembers the eBay debacle, and to be fair to eBay, they're class of the field kind of site, but does anyone know what they built their first site on? Anyone remember the deal they ran? They built it on WebSphere. Massive, tightly knit WebSphere cluster, a highly resilient WebSphere cluster. That didn't end well for them, or IBM for that matter. And the big thing from a software engineering perspective was, we all know about this online business. This concurrency is all fine, but obviously we can't have it there all the time. We need to take it offline a bit, to housekeep or rebuild our indexes or just have a breather. So, couldn't we just do it from 8 till 6? And then the internet suddenly changed all that because people started actually using it the way that they were meant to. And they would sit up at 3 in the morning and try and buy dog food, which was a complete surprise to pets.com, who thought that nobody would buy any dog food overnight. So there was just a new way of thinking about systems, which drove a lot of thinking about software architecture, because up till now, an enterprise system, don't get me wrong, it wasn't easy, but you could take it offline quite a bit, and it had to be kind of secure, but no one was actively attacking it, and it had to be scalable, but you knew how many employees you had, and it had to be quick, but you were paying the employees, so if they had to wait around a bit, they had to wait around a bit. So it was easier. So it was in this era, I was actually in Silicon Valley in this era, and there was this explosion in interest in software architecture. I brought 4+1 into our company. That's the start of my software architecture story, really. I loved 4+1, it was terrific, and then Nick and I directly built on that to write our book a few years later. We absolutely owe everything to the 4+1 model to start with. And so there were meetups, there was a San Jose software architecture meetup, and people started thinking about software architecture. I'm sure the SEI book started selling like hotcakes. During this era, the Software Architecture in Practice book, for first edition, had just come out, so I'm sure, Rick, you were selling a lot of copies at that point. And generally, software architecture came of age. And why? Because once again, it's about necessity. Software architecture is not one of those theoretical disciplines like, say, cryptography, where you think 20 years ahead, produce a lot of primitives, and at some point they become useful. It's very much pragmatic, and this is why it's been so successful. And what were the vendors doing? See first anecdote. The vendors were selling non-functional requirements boxes. Do you need to be secure? You'll be needing a firewall. Oh, do you need to be scalable? Well, we've got a load balancing firewall. Not only twice the price, it's 3 times the price. Do you need to be scalable? You'll be needing an E10000. It's reassuringly scalable. Do you need to be resilient? You'll need 4 of everything. And this was the vendors once again realizing they were about to possibly lose control of the entire story. So what do? People's problems in this era are non-functionals. We're going to sell them hardware devices that solve their non-functional problems. And to some extent they did. It's not as if any of these devices didn't solve some part of the problem when used absolutely correctly and wrapped with a consulting service and 14 outages in the first week as you realized you'd got the firmware wrong and all those things. Eventually, they did help. But if anything, it actually revealed the need for systems architecture, solution architecture, and software architecture, because they were very hard to make very reliable systems out of. So what's going on now? So I think that we are in the internet as a system era. That's one of Google's centers, if you're wondering. They have a marvelous site where they show you inside their data centers, presumably only the ones they want you to see. But that data center, I'm actually not sure which one it is, but probably there are enterprise systems around the world unknowingly routing traffic through that data center as a routine part of business operation, say because they call a credit card service. There's an external service which they call. And the thing that's happened, I've observed in the last however many years, 5 maybe, is that the change in the kind of paradigm, that's an awful word, isn't it? But the big change people want is that they now want mobile user interfaces to be the primary way people interact with systems. Who here uses online banking? That was a worrying moment. I thought nobody. And how many of you primarily use the web browser? And how many primarily use the mobile app? Yes, roughly, I'd say, 2/3 on the mobile app. I mean, certainly I only realized the other day because my bank, the mobile app's got a limitation that I can't pay someone I haven't paid for 3 months. They take them off the list. You have to go back in and sort of validate them once again for security, I guess. I just realized that I hadn't used the website for 3 months because my payee had fallen off the bottom. I nearly always bank through the mobile app. The other thing is, because we're part of the internet, we often want our systems to be consumable via the internet, and that means putting APIs on everything. So those are two things we've had to get used to. And in terms of the demands on our systems, we used to be always on. That was kind of tiresome enough, frankly. But now we're accessed from anywhere. That's because of the mobile first approach. So, I mean, I'm actually a good example of this with services I use like Google or like, in fact, endava's internal services. I get the train to London every morning, so I have 30 minutes on my laptop, reasonably powerful normal computer, and I've got somewhat patchy Wi-Fi on the train. So I could start at home, very fast connection, powerful machine. The same machine goes onto a train. I've suddenly now got a patchy narrowband Wi-Fi connection. I get off the train, laptop goes in the bag, I get onto the London Underground, I take out my mobile device, and I expect to carry on doing roughly what I was doing. Maybe not developing Scala, but if I was reading something, or even if I was making notes, I expect to continue on my mobile device. From a developer's perspective, this is an utter nightmare. You have no idea what situation your end user is in, because clearly the connectivity and the degree of user interface control and the amount of cognitive attention I can pay to the interface changes dramatically from when I'm in my study at home through to being on the London Underground and then back into the office where I'm back into it. So we have to take all these modes into account. And what's happened, I've noticed, is software architecture has become a lot more dynamic. What I mean by that is when I came into software architecture, don't laugh, we were able to draw box and lines diagrams that showed all the bits at runtime, because we knew all the bits at runtime, because we didn't add and take them away very dynamically. That was a bit of an adventure to add and remove bits, especially remove bits, because then you found out the bits you didn't realize were still in use. So whereas now it's much more a case of the architecture is a pattern, and that pattern gets replicated or reduced according to the current needs on the system. Because after all, you get very peaky demand. We're attached to the internet. And also scale, I think, is the other thing, is that because we've decomposed systems down to much smaller pieces, we're dealing with many more bits. So a diagram of all the individual bits is actually rather less useful. Whereas a diagram showing the organizing principles for the bits is much more useful because we can understand it. And what are the vendors up to? You would have thought by now they'd have just kind of accepted that their role is to sell us stuff cheaply and treat us nicely. But no, they still want to control the narrative. So what are they doing now? Well, they're selling us platforms, whether we wanted a platform or not. And in particular, they're very keen to sell us cloud-based platforms, which are marvelous things. I'm a big fan of PaaS, actually. But the caution I always have with PaaS is that why is a vendor so keen to get you on their PaaS? I'll give you a hint. It's not because it's terribly cost-effective for you. It's terribly cost-effective for them, but more importantly, the chances of them being able to tie you into a PaaS that they entirely control is very high. The chances of them being able to tie you into enterprise software that you control is much lower. This is my view anyway as to why vendors want us to use platforms. Of course, the upside is that the reason PaaSes are successful and were created is that these systems are quite difficult to build. You don't have to be Google to find that an internet-connected system is quite challenging. But many of the problems are quality property, non-functional problems, and actually they're relatively repeatable. And if you're IBM, or if you're Google, or if you're Amazon, or if you're Microsoft, or even maybe if you're Oracle, you can create a platform that solves those problems in a very repeatable way. And that's, of course, why PaaSes are a bit irresistible, because put your stuff in the right containers, architect your application correctly, And an awful lot of quality properties will at least partly be taken care of for you by the vendor and their platform. The big trade-off is, by the time you've got tied into all of their deployment tools, by the time that your code is calling all of their internal network services, then you're pretty well on that PaaS for life. It's a lifestyle choice rather than a simple, thing that you'll move off quickly. So what are the architectural drivers hitting us at the moment? One thing is constant competition. If you're on the internet, everyone can see you, and they can see the competition, and they can compare you really fast. And that's not just on pricing. A friend of mine is a CTO for a large international fund manager. They have recently moved into the client, so as in consumer area, and he's noticed a dramatic change in the business's behavior. They used to release sort of 4 times a year-ish internally for their kind of institutional business, and that was seen as fine. Now he's getting requests for change every couple of days. What on earth is this? Well, it's because they've got an internet-facing consumer portal, and all of their internal staff are seeing what the competition's portals do. And the competition's portals, of course, are changing all the time. So they're afraid of being left behind. So it's a constant requirement to change stuff. And there's a constant requirement to be available. Because if you're not available, they will simply move elsewhere. We don't know our users very well because they're all over the world. We don't have the same sort of tight relationship with them that we might have in the past. So we're probably going to measure their behavior rather than send a business analyst to go and have a chat. It's more that kind of interaction. We have very unpredictable demand. If everybody wants to do their banking at 2 o'clock in the morning, that would be a complete surprise, but they could do it. Around a major event, as you know, Amazon go absolutely ballistic. So we have to dynamically respond to load. We're part of the internet, so that probably means we need to be consumable by other systems. We don't want to have to put a human being in the loop for example, digital supply chain. And that means we're visible from anywhere, which, if you're a marketing guy, is a huge opportunity. If you're a security guy, it just keeps you awake at night because you're under constant attack threat. I have a little VM that sits on DigitalOcean in Amsterdam. Nothing on it, literally nothing of any value. It's got one port open, port 22. How often a day do you think it is a brute force password attack en route? Some will be at hundreds and a couple of thousand times a day. And they're from all over the world. There's a lot from China and Russia, as you would expect. But rather shockingly, recently I realised that there was quite a lot from the UK as well. I thought, that's just rude, attacking people in your own country. By all means, attack people on the other side of the world, but leave my VM alone. And being accessed globally, something which architects often think of and no one else has thought of until it's time to ship and then compliance come for a visit, is how are you compliant with regulation right through the world? And if you deal with consumers or you're in financial services or pharmaceuticals, this is, I'm sure, looms large in your life. How do you stay compliant? Well, what happens is that the software architecture discipline, which we all know and love, evolves in order to meet the challenges. So the principles we see people following today are that we need to be able to evolve continually. That's an architectural requirement. You need to be able to respond dynamically. Your architecture needs to have that built in. You need to analyze user behavior. You don't want to be asking people what they want. That's not going to work at scale. You need to make sure there's an API for everything. You need to be secure by design. You need to make sure security is not something you put in late because you're going to connect to the internet where all the bad people are as well as all the good people. And you'll need architects, designers, tech leads to be internationalizing instinctively, and that's not changing the language. That's changing all of the cultural things in the system so that it can be used internationally. For example, don't use red for danger if you're going to be serving Asian audiences. I was told recently that visual signal just doesn't work in that market. And this was something that product companies are historically very good at. They employ people from, at Sybase we supported 26 locales, as we call them, so a combination of geography and language. And we had a department of people who I guess spoke 26 languages. They were just remarkable. They spoke every language in the world as far as I could tell. But they didn't just speak the languages, they knew about the cultures. And the other thing today, which we didn't do so much of then, was you need to understand the compliance environment. So what actual tangible practices then do our teams need to do? What are we leading them to do at the moment? Well, continuous delivery. I was really glad to see there's loads of continuous delivery discussions going on. We're very keen on continuous delivery at endava. I think it's a real competitive advantage. We need people to allow modular evolution because we cannot move a system really It's a single huge monolith. We need to be able to move different modules at different speeds. That doesn't, if Simon Brown was here, he would now be wagging his finger at me going, that does not necessarily mean it's microservices. But it does mean you need to be able to move different parts of the system at different speeds. Cloud first. Cloud's in inverted commas, meaning you need cloud-type thinking. You may well never be able to put this system on a public cloud for really good reasons. But you can use cloud-type thinking, the cattle's not pets type thinking, the automation first, the monitoring from the core. We need to make measurement a basic service. How many of your systems measure enough metrics that you could create a business visible dashboard that the head of the business would understand? Go on, please put your hands up. But actually, a lot of systems don't. Our head of digital innovation in Europe, Bradley Howard, he's a huge believer in creating business visible dashboards, and they're incredibly powerful to show the business, to show where the money went. So what we've got quite a lot of our teams to do is to measure what's going on through the system in technical terms, but then map that to business metrics. How much money has arrived today? How many consumers have we served? How many ads have been served? What was the average margin of a transaction today? Put that on a dashboard, up on a big screen. We've all got a big Jenkins screen. No one cares. We care. No one else cares if it's green or red. As far as they're concerned, it's just colour. However, a business dashboard going, you've just lost £482 million this morning, that really gets their attention. I wasn't saying you made £482 million is even better, obviously. But putting that kind of measurement in allows us to do all this stuff that we talk about learning about our users through data. And actually, especially in the enterprise systems area, I'm just not seeing an awful lot of people managing to do that. Again, it's another lesson we need to learn from the internet-first companies. Maybe not entirely copying Facebook, for obvious reasons, but being inspired by that kind of approach of quantitative profiling. We need to structure our system around public APIs. I've actually thought for years that it's a really good discipline to make sure that all of your internal modules have an API that you would be unashamed of should it be exposed as a public API. But it really helps to keep your modularization solid. And finally, building to be securable. Not everybody can do secure systems development, but they can use basic good security practice, like doing a threat model, like making sure that developers are trained in basic mobile and web app security principles, making sure that, for example, you know whether there are vulnerabilities in your open source. Daniel Bryant was a bit about that kind of thing, how you can integrate that into your pipeline today. There's sort of no excuse today for not having at least some of these checks in automatically. So what's going to happen next? We're going to get intelligent connected systems. My poster child for this is Google Maps. Google Maps knows just a little bit too much about me, because I have an Android and an iOS phone. And my Android phone, when I leave my office building in London between certain hours, and only during certain hours, it pings up an alert on my front screen going, your transit delay to London Euston, that's my terminus, is so many minutes. Your estimated time home is 16:40. I go, whoa, you know way too much about my movements. But it is actually very useful. And Amazon Alexa's, another of these services, ask Alexa a question. Alexa tries to help you rather than simply spit information back to you. The two on the right are things we've built at endava. One's a smart mirror for a high-end New York fashion chain. And what at the bottom is clienteling. That's where when consumers move into stores, you identify the consumer in some way, hopefully with entirely their permission, and then you gather enough information and you get it really quickly onto a device for a salesperson, so that salesperson has the background to go and have a conversation with the client, rather than having to say, what's your postcode, typing it in, and then pulling up all the information, which all breaks the flow and all the magic is gone. So this is what we mean by intelligent connected, and what's going to happen is executives are now using these systems day to day, and they will suddenly arrive at the office 1 January the 1st and go, Google Maps, I've got an Alexa as well, could I have that on the accounting system? And the accounting system team will just look at them and go, obviously not. But actually, within a year or two, they will expect it. I actually had that myself in banking with the mobile revolution. 1 January the 1st, we had a very sophisticated, very big, thick client interface to a big system. The business leaders all came in January the 1st with their iPads going, right, I'd just like that on here, please. And we just looked at them. No, it doesn't do that. But, it had to evolve in that direction. So the impact on us is going to be that we're going to get much better at data and algorithms The reason is that we've often swept those under the carpet and believed that those were things that specialists could look at, but actually they're going to dictate some of the architectural qualities of our systems. Accessing systems everywhere will be great, that will be expected, but people will also expect intelligent assistance, meaning today when you start to use a system, you need to know what you want to accomplish and how to do that in the system. People will expect systems to be making a good guess at what they're likely to be needing to do and to be helping them to do it. Architecture in these systems, these hyper-connected systems, we're going to have lots and lots of data sources, lots of devices, and very large user populations. We're going to know the architecture at runtime by asking the system. And so it's going to change the way that we do our architecture work. And the vendors are not going to go away, and this battle is already starting. They are trying to sell us intelligent behavior packaged as software as a service. And this is going to be the next big battleground to get us locked into their platforms because their intelligent services will be so compelling. Or that's the argument. And this is going to mean we're going to do a bit less structural design. I think we're going to be much more worried about data and algorithms than we have been. There's going to be a less detailed defined structure up front and more structures that emerge at runtime because they're so big and there's so many moving parts. Actually trying to do very detailed defined structures won't make sense. I think we'll be making less one-off decisions and we'll be doing more policy-based architecture. So we'll have a policy for the structure of the system, which hopefully some automated software will be implementing rather than just developers. And rather than certainty, we're going to be dealing a lot more with probability. This is something actually in the test discipline in endava. I've set this as a grand challenge for my test discipline, which is how do you test an AI system? Today our testers are used to having systems that reply with great certainty, and they know whether it's right or wrong. So an AI system, there is a probability that its answer is useful to a probability. It's a much harder thing to test. But as soon as we get to more scale and much finer pieces, there's going to be a lot more of that right across software architecture too. And finally, today, when we get involved in operations, we tend to get involved in helping them define processes. Our ops guys love a good process. Well structured, written down. They're very good at implementing them, good at automating them. Actually, at scale, and I'm sure if you peep inside the Googles and the Facebooks, they're there already, we're going to be having tools that need us to define operational policies and then semi-intelligent tools that run them for us. So in summary, we've had a real ride so far, and software architecture has been a great place to be. From going from program structures through architecture merging with client-server, it having its explosion and understanding quality properties in the internet-connected era, to today, where we've got it to a really quite a sophisticated level of practice at the sort of front of the mainstream. The next phase is going to require us to rethink some of that and to move our priorities. Just as our priority isn't anymore on the structure of the code, it's today much more on things like continuous delivery, that's going to have to move again. Continuous delivery will be a given. The question is, do we have the right data in the system to provide intelligent behavior? Just one example. So I think the future of software architecture hasn't ever been more exciting. But actually, I don't think it's ever been less certain either. We just don't know what the next phase looks like. What I can say with absolute confidence is, it will be a great place to be. We've enjoyed it so far. We will enjoy the next bit too. And the discipline will react, and it will produce pragmatic solutions which make the industry better. Thank you. And those of you who said Owen Woods in a 30-minute session, turns out you were right after all.